The trigonometric functions, including the reciprocal functions of secant, cosecant, and cotangent, all have their own derivatives. Let's start with sine and cos. The derivative of sine is cos, and the derivative of cos is negative sine. You don't have to remember these, including all the others, because they are in the information booklet, which is supplied with all exams and tests. Here's an example. Derivative of x squared minus sine x with respect to x. Notice this is a sum or difference. Your derivative of a sum or difference is the same as the sum or difference of the derivatives. So we're going to differentiate x squared minus differentiate sine of x. Notice there we are. Sine of x goes to cos, so there is sine going to cos. Let's have a look at a product. Derivative of product is u prime v plus uv prime. So we're going to differentiate that, leave that as it is, plus leave that as it is, differentiate that. Simplifying cos x minus x sine x. Let's differentiate a quotient. There's the rule for quotient, u prime v minus uv prime all over v squared. U prime v minus uv prime all over v squared. That's if we're differentiating u over v. Two functions in x. Your u here is sine and your v is x squared. So, u prime, derivative of sine x is cos x, and we have the v as it is, minus, don't confuse with the product which has a positive sign there, the quotient has a negative there. Then we'll have u as it is, sine times v prime, the derivative of the denominator, 2x, and it's over the denominator squared, which simplifies to that. Let's have a look at this one. This here is a composite function using chain rule. Note here we need to use radians in calculus. You will never see degrees in calculus. We square angles, we do all sorts with them, so we cannot use degrees. So that's pi. Pi is 180 degrees if you want the equivalent. So the outside function is cos, and the inside function is 2x plus pi, pi being a constant. So it's derivative of the outside function, leaving the inside as it is, times derivative of the inside function. So cos, we differentiate, goes to negative sine, and it'll be of exactly that bracket, times by derivative of the inside, 2. Pi goes because it's a constant. And just placing it in a slightly neater arrangement, there we are. Now the other 4 reciprocal ratios all have derivatives as well. Remember there is, well, that's tan, that's not a reciprocal ratio. Of course, tan, its derivative is a reciprocal ratio, sec squared. Secant is the inverse of cos. Derivative of cotangent of cot is negative cosec squared. Cosec is the reciprocal of sine. And sec, the reciprocal of cos, its derivative is sec x times tan x. Very interesting the way it comes back at us. And of course, cosec is negative cosec x cot x. Same pattern as the previous one with the negative, and this is the same pattern as the previous one with a negative. Once again, you don't have to remember these. These are in the information booklet. But it can be proven easily using rules of differentiation, and I'm going to go through them now just to give you more information about trigonometric derivatives. But in the PowerPoint, if you go through this very PowerPoint, it actually it misses those out, but you'll see here, if you wish to see the derivation of one of these derivatives, click on the particular derivative. That will take you to a slide going through the particular derivation. Notice with derivation, we're not differentiating, it's derivation of the derivative. To return to the slide, click the return in the bottom right-hand corner. So let's click on the derivative of tan. There we are. Tan, there's the return in the corner. Tan, we always go to sine over cos. There is a quotient rule, so it's going to be derivative of sine times cos minus a sine times derivative of cos, all over cos squared. Simplifies to that, and of course that there is the Pythagorean ratio equal to 1. So we have 1 over cos squared, which gives us our sec squared. Returning, let's have a look at cot. Cot is the inverse of tan. It's the, shall I put it this way, it's the reciprocal of tan. So, cos over sine, we're going to go through the same process. Derivative of cos times sine minus cos times derivative of sine all over sine squared. Simplifying, we have two negatives, so we can take out negative, and we have that Pythagorean identity equal to 1 again. So therefore negative 1 over sine squared, and that is negative cosec squared. Derivative of sec. So there we are. We're going to write that as 1 over cos. That means it's cos to the minus 1. So that is now a chain rule. The outside function, u to the minus 1, and the inside function, cos. So differentiating the outside function, minus 1 comes down, cos x to the minus 2 times, and that's the derivative of the inside. In this first, when we differentiate the outside, the inside stays the same. That becomes sine over cos squared. The negatives cancel one another out, and cos squared goes to the bottom. Now we do a neat little rearrangement. We'll take sine over 1 of the cos and put 1 over cos separately. And there it is. There's your sec, and there's your tan. And finally this one, cosec. Well, that's 1 over sine. So it's sine of x to the minus 1. Using chain rule, minus sine x to the minus 2 times derivative of sine of x, which is cos x. The minus stays in this case, cos x over sine squared. We do that neat little separation again. We're keeping cos over sine because that's cot, and 1 over sine because that's cosec. And there we are with that derivative. Let's continue with some examples. Using chain rule. There's chain rule, which we've been through a few times. F of x equals sine of x squared. Now note here, the sine is not being squared, only the x is being squared. So the outside function is sine. F of x is equal to sine of gx, where g of x is x squared. So the outside equals sine of the inside, and inside equals x squared. So this gives us sine of x squared goes to cos of x squared, derivative of the outside, leaving the inside as is. And now we differentiate the inside. And that gives us our 2x cos x squared. Now we have the sine squared. Now the sine is being squared, not the x. That makes a big difference, because now your outside function is actually the squaring. So the outside function is a square and the inside function is sine of x. So we're going to differentiate the outside function by saying 2 times the brackets all to the 1, and we leave the sine of x inside. There it is there. Derivative outside, leaving the inside as is. Now we have to differentiate the inside, and derivative of sine is cos, so it's times cos. And if you know your double angles, 2 sine cos is sine 2x. Now let's have some examples. Here they all are so that you can, just to remind you, so you don't have to memorize them. Number 1, well, that's just a sum of 2 functions, so differentiate, differentiate. Derivative of cos is minus sine, so that's how the sign is changed there. Similar sort of thing, except we're going to have to write that 3 over x as 3x to the minus 1. Now we can differentiate normal way, so that becomes minus 3x to the minus 2, and that plus 5 cos x. And we can simplify it to minus 3 over x squared plus 5 cos x. Straightforward, except we'll have to write the root of x as x to the half. So there we are. Now each of these has a derivative. The derivative of cosec squared, cosec is negative cosec cot. Derivative of 4x to the half, multiply down by the half and subtract 1 off the half. Negative 7 as a constant goes. And we'll write with a positive exponent. Number 4, we have a product there. So now, when we differentiate, that becomes 0, and that there minus, and then that's x squared times sine of x. So derivative u prime v, there's v, there's u, plus u v prime. That's as far as it can go. Next one, x squared cot x minus x squared, much the same sort of thing. We're going to write x squared cot x minus x to the minus 2. Now we're going to differentiate that as a product. U is x squared, v is cot x. So u prime v plus u times v prime. Remember, the derivative of cot is minus cosec squared. And then this one minus multiplies down, changing it to plus 2x to the, subtract 1 off there, minus 3. And a bit of a simplification, mainly to write the negative exponent as positive, but it's good to neaten things up a bit. Sine plus cos times sec x. Now a reminder, cos and sec are reciprocal functions. So that's cos and that's 1 over cos. So when you multiply them together, you'll have cos over 1 times 1 over cos, and that gives you 1. So sine x times sec x, there it is, and plus 1. So when we differentiate, we're going to use the product rule for this one, and the 1's going to go being a constant. Derivative of sine, cos, at sec stays the same, plus sine times derivative of sec. uv times u prime v plus u v prime. Cos times sec becomes 1. This could simplify further. You could write, no, you couldn't actually. There's nothing to simplify in this one. Right, cos over 1 plus sine. Well, that's a quotient rule. So therefore, derivative of the first minus sine times the second as it is, minus, for quotient rule, cos times derivative of 1 plus sine, which is cos, all over v squared. So that simplifies to that. And I notice that I have a minus sine squared minus cos squared. So I'm going to take them a negative out. So now I have our Pythagorean identity. So I write that it's minus sine x minus 1 all over your 1 plus sine x all squared. And I'm going to write that at theta. I'm going to say, well, that's fine. That actually is the same as minus 1 plus sine x. So when I take out the minus and put it there, 1 plus sine x, one of them cancels with the one below. So we're left with 1 over 1 plus sine x. Number 8, there's a product rule. Each of them is a composite rule as well. So when we differentiate sine of 3x, the outside function is sine of, so it becomes cos of 3x. And the inside function is 3x, so it becomes 3 when differentiated. So this here is u prime, and that there is v, plus u, so there it is u, and then v prime, so derivative of cos of something is negative sine of that something, staying as it is, multiplied by derivative of the inside, 2. And that's a bit of a simplification. Right. This here is a composite function. The outside function is cos, the inside function is cot. So we're going to differentiate the outside function, so that becomes negative sine of, and cot stays the same. Then multiply by, and we're going to differentiate the cot. So negative sine of cot x, and then multiply by derivative of cot x, which is negative cos x squared x. And we just make allowance for the double negative.